Hello everyone, welcome back to the course Financial Mathematics for Actuaries. In this session, we are going to learn the bond valuation using some numerical examples. In the last sessions, we have already understood how to compute the yield to maturity, and we have also understood the basic price formula for bond evaluations. Today we will continue to use this basic price formula, and also we will see a similar formula, okay, that is known as the Markov formula. Let's begin the course now. Okay, so we have understood that our basic price formula for bond evaluation is P is equal to FR, okay, A angle N given the rate of interest plus m v to the power m, where m is understood as the redemption value, in which case sometime we have used it as c. Okay, so this formula also we have understood in the more simple way, that is fr multiplied by present value interest factor for annuity given I the effective interest rate and n is the time period plus c is the redemption value here, which is m, and that multiplied by present value interest factor for the simple calculation here with I effective interest rate and n is the number of time. Okay, so let us take an example here to extend our bond evaluation thing. Okay, so suppose the following information about a government bond is given, that is we have the issuing date, okay, we have the maturity date, okay. So issue date may is there, that is in 2010, and maturity date, that is February 2040. Here mostly this is February 15, again like the same, it should be same, okay, February 15 2040. So the coupon rate is given. Coupon rate is the rate of interest which is mentioned in the face of the bond, that is 4.5% payable semi-annually. Okay, so every 6 months the coupon payment is to be made, and yield rate, which is I here in our equation here. So yield rate is also given as 4.53%, which is convertible against semi-annually. Okay, so we will again compute. So in for our example here, to use in our example, we will divide this by 2 to like use this I. Okay, and now we also assuming that the redemption value is equal to the face value, which is given as $100. So find the price of the bond. Very simple. So we can directly use the formula to get the answer here. Okay, so we are given as f is equal to 100 and the redemption value, that is c, which is also equal to m, is equal to 100, and this will tell us that c is equal to f. So the coupon payable semi-annually, so as I have already mentioned, r, which is 4.5%, that will be divided by 2, which will give us 0.0225, and yield rate, that is 4.53% convertible semi-annually, again which will give us, by dividing by 2, we will have 0.02265, and n is that is 30, and it is that the coupon is payable semi-annually, so we will just multiply this by 2, so n will be 60. Instead of 30 we are going to use 60, right. So FR, that is the coupon amount, will be 100 multiplied by this one, that is 0.0225. So, we will get 2.25, which we are going to use in our formula. Okay. So, let us use the formula which says P is equal to FR A angle N at I plus C B to the power N or M B to the power N. Okay. So, which will again rewrite using the values, we will have this one, right. So, we will have here P is equal to 2.25, that is the FR we have just calculated, multiplied by A angle N is equal to 60 and I is equal to 0.2265, okay, plus the redemption value is equal to 100 multiplied by 1 plus R, or sorry, 1 plus I here in the effective interest rate we have to use. So, 1.02265, okay, to the power minus 60, okay, or to be we like simplify it more clearly, we will have using the formula for the present value interest factor for annuity, that is 1 minus 1 plus R to the, or 1 plus I in our case here, 1 plus I to the power minus 60 divided by I, okay, that is 1 minus 1.02265 to the power minus 60 divided by 0.02265, and then this one is exactly the same thing, I have written it here. Upon calculation using the calculator, we will get this value is 32.6338. I have already calculated it for the example here, and therefore I have directly written. You can also check yourself by like using your calculator, you will get the same value. So, 2.25 multiplied by 32.6338 plus 100 multiplied by 0.2608, which will give me the P is equal to 99.51. Okay. So, $99.51. Okay. So, let us take another example. Okay. Example 2, in which case the following information about the bond is available. The bond is the government bond, okay. Issue date is given as June 15, 2005 and date of purchase is given as June 15, 2009 and maturity date is 2020. Okay, coupon rate is given as 4.2%, payable again semi-annually. Yield rate is given as 4.0%, convertible semi-annually. Okay, assume that the redemption value of the bond is the same as the face value, which is $100. Find the purchase price of the bond immediately after its 8th coupon payment on June 15, 2009. So, when you purchase, okay, like on June 15, 2009, the 8th coupon payment is already been made, okay, and therefore, okay, the question is find the purchase price of the bond immediately after its 8th coupon payment. Let's do that, right here. So, this problem is basically a 15-year bond, okay, the 15 years bond at issue, but there are only 22 remaining coupon payment, okay, or coupon payment periods after our 8th coupon payment has been made. So, using the basic price formula again, okay, with the given information, that is F is equal to 100 and C is equal to 100, okay, and R is given as 4.2%. So, you will divide this by 2 to get the R to be used, that is 0.021. This one we are going to use to compute the FR, and this one, this is the yield rate, okay, the effective interest, we will have that is 0.040 divided by 2, we will get 0.02. We are going to use this to compute the present value interest factor for annuity and present value interest factor for the bond, okay. And n is also of course the 22 remaining coupon payment, that is n is equal to 22 here, okay. And upon computing the FR, where R is equal to 0.21, we will have, okay, FR is equal to 2.1. So use this information in our basic price formula here, okay, and then rewrite the basic price formula as P is equal to 2.1 multiplied by A, n is equal to 22 and I is equal to 0.02 plus C is equal to 100 multiplied by, okay, this 1.02 to the power minus 22, okay. Using the formula again the way we have already used it, okay, we will have FR, and then this is the formula for present value interest factor for annuity with the n is equal to 22 and I is equal to 0.02, we will have 17.658, okay. And here we are we can use our calculator to compute this. 1.02 raised minus 2 will give us 0.6468, okay. And then upon calculation we will have, okay, this person is 37.0818 plus 64.6839, okay. So the price of the bond is equal to 101765. Okay, what we have noticed here in the earlier case, we have seen that the price is actually less than the face value, but in this case the price is little bit higher than the face value, that is 100 rupees. So in this is a premium bond and the earlier one is the discount bond, therefore, right. Okay, so let us do the bond evaluation for a zero coupon bond. I believe you have already understood what is zero coupon bond. In case of zero coupon bond, you will not get the periodic interest rate because zero coupon bond does not have the interest payment, but, okay, upon maturity you will get the same value written in the face of the bond. Take this example to understand the bond valuation for a zero coupon bond. So find the price of a 18-month zero coupon bond with redemption value of the same $100. The bond is bought to yield 4.24% convertible semi-annually. Note that the basic price formula can be used for a zero coupon bond, in which case we will simply put R is equal to 0, where R is the coupon rate, okay. In zero coupon bond there is no coupon, so we will have 0 or R is equal to 0, okay. So using this our basic price formula, therefore what basic price formula is P is equal to FR, okay, A angle N at I plus C to the power CV to the power N. This is our basic bond price formula. So with R is equal to 0, okay, or here we will have this is the, like with R is equal to here sorry, for this entire term will equal to 0, so we will only have P is equal to, okay, this will lead P is equal to C V to the power N, okay. So now we are going to use this formula, right, fine. So we have now here is Okay, given that the yield rate is 4.24%, okay, convertible semi-annually, we have to divide this value by 2 to use it in the formula. So we will have I is equal to 2.12%, okay, and n is equal to 3. Okay, so every it is a 18-month zero coupon bond, so like we will have 18 divided by 6, we will have 3. M is equal to 100. So we have the P is equal to this. So this will become 0. We will get, okay, P is equal to only 100, that the redemption value or the face value, multiplied by 1.0212. This is this one, okay, to the power minus 3, which will give us 93.90. So the price of the bond today is $93.9. That means if you are willing to buy this bond, then you are going to pay this much amount for this bond with the expected yield rate is equal to 4.24% convertible semi-annually. Okay, this is how we understand the bond valuation. Okay, for zero coupon bond, the first part or the first component will be equal to 0, and we will only use the second component, this one. Okay, right. Okay, so let us now understand another formula, which is an alternative formula for basic price or basic bond pricing formula, which we can see we can use the basic price formula to divide to derive this formula also. This is known as Markham formula or Markham formula. It is the financial formula used to calculate the purchase price of bond. Okay, basically it simplifies the bond pricing by breaking it down into two components. One is it will take the redemption value or discount, it will discount the redemption value, okay, and again the present value of interest payment, right. We can derive this Markham formula using our basic price formula, and therefore, as I have already mentioned, this formula will exactly same as the basic price formula. Okay, so given that price is P is equal to price and C is equal to the redemption value, which in our case we have assumed that this M, which is maturity value, is also redemption value. Okay, and K is given as CV to the power N, which is the present value of redemption. Okay, and V is the discount factor. We can use the modified coupon rate. G is the modified coupon rate, which is equal to FR upon C, which is equal to the coupon amount. This is FR is the coupon amount divided by the redemption value, and therefore this is also known as the modified coupon rate. With the yield rate or the effective interest rate I, the Markham formula says P is equal to K plus G divided by I times C minus K, in which case K is equal to C B to the power N, okay, and G is equal to FR divided by C, okay, I is the effective rate. Okay, so let us now derive the makeup formula. So the Markham formula is this one, right? Okay, let us now prove it. So rewrite the basic price formula as P is equal to FR A angle N at I plus C V to the power N. This is the way we have already understood now. Okay, so no need to confuse about C and M. So we will continue now using the C, okay, as to consistent with our book, right. Remember, we are following the book Financial Mathematics for Actuaries by Chan and Se. Okay. So P is equal to FR, and therefore 1 minus V to the power n divided by I plus K, since we have already understood that okay we have understood that this K is equal to C V to the power n, and note that given G is equal to FR divided by C, we can compute FR is equal to Cg, and therefore you will replace the value of Cg, okay, value Cg, okay, for FR here, and therefore I have written here C multiplied by G, okay, time 1 minus V to the power n divided by I plus K, okay, and we will take this G and like take this I out, so we will have G upon I, okay. So multiplying this C with 1 and C with this, again we will have, okay, C minus C V to the power n, okay, plus K. So these are the same, this is just simplified, which implies that P is equal to G by I, okay, multiplied by C minus K, because we are like C V to the power n is K, plus K, okay, or we can simply rewrite the way we reflect P is equal to, okay, K plus G by I C minus K, which is known as Markham formula, and hence proved, right. So this formula therefore will give us an alternative way to compute the price of the bond, but we have already understood the basic price formula, that is, okay, P is equal to FR time A angle n at I plus C V to the power n, right. Okay, so I believe you have now clearly understood how to compute the bond price in different situations also, okay, and with a zero or for a zero coupon bond also, and now you have also understood one alternative formula known as Markham formula.